Hello everyone, this is Mr. McMillan. I'm here with a video on some basic concept review on arc length, sector area, and angles and arcs and circles. So we went over these the past couple weeks in class, and I want to make sure that we understand the different formulas as well as how to work out some of these problems. Now in this video, we're going to be going over these formulas, talking about what we need for each type of problem. And then in the, after this, what else is posted on the assignment part are some practice problems with these concepts, okay? So make sure that you are attempting those problems, it's very important that we do this because, you're likely to see things like this on the end of your test. So make sure you have looked over all those. So the first thing here that we're going to talk about is the arc length. And the first thing that we talk about arc length is that the arc length is this portion on the edge of the circle. Okay, so it's on the portion on the edge of the circle, and that means that the arc length is a fraction of the circle's circumference. So it's a fraction of the circle's circumference. Okay. So what that means is that if we can figure out what the fraction should be of this circle for the circumference, then we have our arc length, and that goes for any given length around the circle, okay? So there's two pieces of information that we need to determine the arc length, and the first that we need is always our radius, okay? So we need our radius, which is r. And we also need our angle. And that's represented by theta. Now that angle might be your central angle like it is here. The central angle and its arc are the same. Or the arc could already be labeled with the arc or with the theta. But make sure when you're doing arc length, that's different from what the arc itself measures. The arc length is a distance, whereas the arc measure is a degree. So our formula, it's a fraction of the circle's circumference. Now you're talking about the theta, the angle part, being the piece of your circle. And if you remember, fractions mostly take place of your with your parts over your whole thing. So your part here would be theta. So that's going to go on top first. So that's your first part of the fraction. And then it's going to go over the whole thing. Now, if you think about the angle in a circle, if you go all the way around it, how many degrees have you went? Well, you've went 360 degrees. So your fraction here is going to be theta over 360. But that's not all. That's just our fraction part. So this is our fraction. Next, in the parentheses, we're going to have to do its circumference. Now, the circumference of a circle is given by the equation with the radius. C equals 2 pi r. So this whole thing in the parentheses is your circumference. All right. So that's why you need theta and your radius, because theta, your angle, is what you're going to have for your fraction as well as your radius, which is needed for the circumference. All right, so next up, we're going to look at sector area. And like arc length, for sector area, you are also going to need your radius r and your angle theta. Okay, so you're going to need radius r and the angle theta. Now it's a bit dark here in this, and I do apologize. The scanned version looks much better. But the printed version that I'm using, the printer decided to just make a bunch of black streaks in there. So apologies for that. But there is a theta in there somewhere. Okay. So what we're going to do here is determine, what it should be a fraction of, because it is going to be a fraction. As you can see, it's just a piece of that circle. So this is a fraction of the circle's what? Well, it's called sector area. So if it's the sector area, then it should be a fraction of the circle's area. Okay. So just like before with arc length, our sector area is going to start out with the formula A equals, and then you're going to have your fraction. Well, your fraction still has not changed. You still have your theta over 360. So that's still the fraction. But what is going to change is what's in the parentheses, because instead of the circumference being in the parentheses, this time it's going to be the fraction. So the fraction, or sorry, your area, excuse me. And your area of a circle is given to you by pi r squared. Okay. So you take your fraction times your area, theta over 360 times pi r squared. All right, so now let's get back into some more recent stuff. This is the different types of angles, of which there are 4 in a circle. And the first one is the simplest of them, and that is the central angle. Now, in each one of these, we're going to talk about which or where the vertex is, and then talk about how to determine the angle measure and the arc measure. So the central angle, as its name implies, the vertex of the angle is located at the center of the circle. Okay, so a central angle is a vertex that's located at the center of the circle, and you have to have that angle there. So you can see you have the 2 radii there attaching to the center in order to form a central angle. Now, the important thing about a central angle is that the central angle and its arc, so the central angle and its arc are equal to one another. So that means that the angle is equal to what the arc is, and vice versa. So if you had a 74-degree angle here for your central angle, then your arc would be 74 degrees as well. Okay? All right, so let's talk about the inscribed angle next. All right, so now we're looking at the inscribed angle. And the important thing about an inscribed angle is where the vertex is located. Okay, so the vertex of an inscribed angle is located on the circle itself. So it's on the edge of the circle. It's part of the circumference. Okay. So anywhere, if you have an angle that has a vertex originating on this, on the circle's edge, then it is an inscribed angle. Okay. So with an inscribed angle, you have to be very careful about that. And also you have to be a little bit more careful because it's not just as simple as the angle is the same as the arc. For an inscribed angle, the angle is half the measure of what the arc is. So it's half of what the arc is. Okay. So in other words, if the arc that I have here was equal to 150 degrees, then the angle would be half of 150, which is 75. But that also brings about another relationship between the angle and the arc. What if you had your angle, but you didn't have your arc and you wanted to find it? Well, if the angle is half the length of the arc, then the arc must be twice the measure of the angle. Okay, and as you can see here, your arc is 150, which is double what 75 is. All right, next up is our interior angle, and this one trips most people up just because of the way we think about interior and all that. So the vertex for an interior angle is located inside the circle. But not at the center. Okay, so the vertex is inside the circle, but not at the center, as we can see here. So, unlike the central angle and inscribed angle that only required one arc to determine what the angle measure was, this time the interior angle takes two. And specifically the ones that it wants is the ones that are opposite from the vertical angles that you're using. So here, you've got this angle here is opposite this one, so you use that arc there with the X. But you also use the one opposite from its vertical angle, which is this one here, which is Y. And to determine the angle measure of an interior angle, you take your angle, and it's equal to the sum of the two arcs. So arc plus arc divided by 2. Okay. And the way that you can try and remember a little bit better is that you're talking about interior angle. If you're part of a group, you know, you're inside that group circle, you know, you are an addition to that group. You're adding some value to that group because they appreciate your company or whatever else. So for an interior angle, you're going to add, you're doing addition. Okay. Now let's look at the last type of angle we've talked about, and that's the exterior angle. And the thing about the exterior angle is, unlike the interior angle, the vertex is outside the circle. Okay, so your vertex is outside the circle. And just like the interior angle, this requires two different arcs. But your two different arcs are the ones that are formed by the intersecting lines that the legs of the angle are made of. So here you've got a big arc and a small arc that you use. Now, if you added for the interior angles, you're going to do the opposite for the exterior, which means you take your big arc minus your small arc and divide by 2. Okay. And so that's a recap of all the formulas that we did. If you are interested in going back and watching them on the Google Classroom page or whatever else, look for the ones that talk about arc length, sector area, and the different types of angles. For arc length and sector area, this is in week 9 videos. So you can see some examples. And the other one, the 4 types of angles in circles, are in week 10. Specifically, the very bottom one for week 9 on that list is a bunch of examples for arc length and sector area. I go over them step by step. And week 10, the last 3 are ones that have examples where I go over them step by step. But yeah, so that's it for this one. You know, make sure you're looking back over those. There are some example problems here, or not example problems, but some problems to work out for these. So yeah, just make sure you work on those. Thanks guys, and I will see you in the next video.